All right. So I think when we passed this out, we did the first problem together. Am I right on that? I did on the video. I did the first one. Okay. Okay. So you're right. I wasn't here yesterday, but I knew that we did. But if you watched the video all the way through, you would have seen me go through the first problem. All right. Okay. So let's motor through that real quick. Yeah, why not? All right. For A, what would we put there? 5 solutions. Great. Where are you getting the 5 from? The biggest exponent in the problem. The rational roots theorem. So what's my list of possible rational solutions? Excellent. So plus minus 1, 2, 4, and 8. Okay. Next up, we're going to type this guy into our calculator. Did I start this yet? Okay, good. Type this into our calculator and take a look at the picture. So this is a really important part, to get this stuff into your calculator and get a picture to come out that's reasonable. That's going to be problems. Oh, shoot. Anyways, in the future, so we got to make sure we're able to do that. So I just typed it in exactly as it appears, picked my window with the x's going from the smallest to the biggest thing on my list, and then I'm going to hit graph, and I'm going to look for the places where the graph is crossing the x-axis. So it looks like -1 and +2. You guys agree with that? So if I compare my answers for B and C, are either of these two solutions irrational? No. Why not? -1 is on my list. +2 is on my list. If I got things that aren't on my list, that's what the irrational ones would be. Okay? So here we have none. All right, next up, we're going to use the bend, bounce, and straight theorem. If I look at -1, is that a bend, bounce, or straight? That's a bounce. Okay. If I look at x equals +2, bend, bounce, or straight? Bend. Okay. So bounces can be used how many times? Even greater than or equal to 2. So at least 2. 4. Could I be used 6 times in this case? Why not, Catherine? Because there's 5 total solutions. So no way this one could be used 6 times. Great. Bends, how many times can those be used? Odd, greater than 3. So 3 and 5, right? Could I be used 7? No, because 5 is the number of solutions I have. Now, could I really be used 4 times or 5 times here? Could -1 really be used 4 times? No, because this one has to be used at least 3, and 3 plus 4 is 7. Similarly, it can't be used 5 times because the other one has to be used twice, and 2 plus 5 is 7, and that's too many also. So we know exactly how many times things are going to be used here. So I'm going to set up my table. I have all my x-intercepts. I have a space for my irrational things that we said there weren't any, a space for possible imaginary things, and then a total. The total we know is 5. This one we said could be used 2 times. That one could be used 3 times. 2 plus 3 plus 0 is 5. That means there can't be any imaginary ones in this case. So what the table's going to do is help us indicate if imaginary solutions are possible. Here they're not. We don't have any room. All right. So let's start our synthetic division then. So I'll use -1 first. It doesn't matter which one of the x-intercepts you use first in this case. Okay, so that worked. That's great. I know it can be used 2 times, so let's just use it again. So that worked. So now I'm going to switch to 2. So that worked. Great. Now I could stop here because the polynomial I'm left with is quadratic, and I should be able to factor that if it's factorable. Or I can continue doing synthetic divisions. It doesn't really matter. I'm going to just, for the sake of argument, do a synthetic division here. So that worked again. So let's see what I have. So because -1 gives me a remainder 0, that means I have an x plus 1. Because -1 gives me a remainder 0, it means I have a second one of them. Because +2 gives me a remainder 0, that means I have an x minus 2. Because it happened again, I have a second one. And then this down here is also an x minus 2. So if I want to put that all together in the most compact way, I could write it that way. Everybody okay with what I did there? So now that that's in factored form, it should be easy to solve. I just set each of these factors equal to 0 and then solve. So I get -1 twice and +2 3 times. So that's the first one. Okay. For this next one, number 2, what do you guys get for part A? 4. Very good. How'd you get 4? It's the biggest exponent. Good. Okay. How about the list of possible rational solutions? This one's going to be kind of long, right? So plus or minus 1, 3, 7, 9, 21, and then 63. And then I have plus or minus 1 over 2, 3 over 2, 7 over 2, 9 over 2, 21 over 2, and 63 over 2. And I have 1 over 4, 3 over 4, 7 over 4, 9 over 4, 21 over 4, and then 63 over 4. Okay. So let's go ahead and graph this then and look for our solutions. So I'm going to go from -63 to +63 as those are the biggest and the smallest. Now I'm sure I'm going to have to zoom in a second time on that, but okay. So I saw a little bit of stuff happen here right close to the y-axis. So this is like -60, -30, -15, -7. That should be good to capture everything I'm interested in between -7 and +7. Okay. So what are the x-intercepts we see there? What do you estimate that one as? Negative 2 point what? You're just estimating. It's not a wrong answer, as long as you're reasonable. What's the decimal point? Negative 2 point. Okay, sure. It's awful precise, but okay. And how about this one? What is this one? Well, what is it? What is this one? Okay, sounds good. And then what is this one? Okay, sounds good. All right. So now let's compare these answers to what we have on our list. I see I have negative 1.5 right there. Do you see negative 2.75 anywhere? 7/4 is 1.75. 9/4 is 2.25. 21/4 is 4.75. So I don't see it, do you? Nothing's really very close to it even. Probably negative 3 is the closest thing that's on there. And it's definitely not at negative 3. So it looks like those two guys are irrational, because I don't see them on my list that I just made above. Everybody good with that idea? Okay. So negative 2.75, what is that? Bend, bounce, or straight? Straight. How about positive 2.75? What's that? Also straight. How many times are straights used? Always one time. The negative 1.5, what's that? Bend, bounce, or straight? Bounce. How many times are bounces used? 2 or 4 or 6. Can I be 6 though? Why not? There's only 4 total solutions. Could I even be 4? No, why not? Because I have 2 solutions already there for each of those straights. So really I'm limited to 2 solutions. Everybody agree with that? Okay. So I have x equals 2. I have my irrationals, my imaginaries, and my total. So x equals 2 is going to, or I'm sorry, not 2. I don't know why I wrote 2 down. That's dumb. Negative 1.5 can be used twice. I have 2 irrationals. That gives me the 4 total that I need, leaving me no room for imaginaries. So I can't have an imaginary in this situation either. So the only rational solution I have is this negative 1.5. So I'm going to start with that. That's going to be 48, negative 48, and that's going to be 63. Okay, so that worked. I know I can do this twice, so I'm going to do it again. Yeah, I know that should be a 4. I was going to say, that doesn't look right. It's giving me a negative 6, negative 28, and that gives me positive 48, so that gives me 0 also. Okay. So because negative 1.5 gives me 0, I have an x plus 1.5, and because it worked twice, that's the second power. And then this stuff gives me a 4x squared minus 28. Now this is my factored form, but this looks a little weird. Why does this look weird? I have decimals in my factor. So it turns out we can rewrite this a little bit to get rid of those decimals inside of the factor, because it's a little strange to give a polynomial that has all integer coefficients that factors into factors that have decimal coefficients. It's a little strange. But if you take a close look there at 4x squared minus 28, you'll notice that there's a greatest common factor of 4. Does everybody see that? So I'm going to factor that out, but instead of factoring out a 4, I'm going to write it as 2 times 2. Because what I'm going to do is I'm going to distribute one factor into this and one factor into that one. So 2 times x is 2x, and 2 times 1.5 is 3. And then I still have the x squared minus 7. Now I have a factored form that has all integer coefficients, which makes a lot more sense when I have a polynomial that has all integer coefficients. Everybody okay with that? Okay. So then I take each of these factors and set them equal to 0. So this one I get negative 3 over 2 for each of those. This one I'll add the 7 over, and then I square root both sides to get me x equals plus or minus square root of 7. So there's my 4 solutions. Okay. Move on to number 3. For number 3, part A, what did you guys get there? 6. Good. Everybody's good with how we got 6? Okay. How about part B? Good. I wrote them in ascending order rather than the order that Nancy read, but that's fine. Either is fine. You just have to have them on there in some order. Okay. Let's take a look, fire up our calculator here. So I'm going to graph this from negative 12 to positive 12. Again, those are my biggest and smallest ones for my list. Okay. So I think I can see what's going on, but I can't really tell if those are touching or not. So I'm going to zoom in a little bit more. This one looks like at negative 2 or negative 1, and that one looks like at positive 2. So maybe I'll just go from negative 3 to positive 3. Okay. So I'm now confirmed that what I thought I saw is what was really going on. Are any of these irrational? No. How do you know? Both of those answers are on our list, right? Okay. So what is negative 1? Bend, bounce, or straight? How about positive 2? Bend, bounce, or straight? Okay, both bounces. How many times can bounces be used? An even number of times, so 2, 4. Can it really be 6, though? Not if there's 2 sets of them, right? Okay. So let's make our table here of possible solutions. So the total here is 6. So if both of these are 2, we know there's no irrationals. 2 plus 2 plus 0 is 4. To get to 6, we must have 2 imaginary ones. If this one is 4 and this one is 2, that's always still 0. That gives me 4 plus 2 plus 0 is 6 already. So it can't be any imaginaries. And likewise, if this one was 2 and that one was 4. But could they both be 4? No, because 4 plus 4 is 8, and that's too big now. So it's one of those 3 situations. We're not sure which one. The takeaway here is, though, that for the first time, it's possible that we can get an imaginary solution here. We don't know that that's what's going to happen, but it's possible. The other 2 times, it was not possible to get an imaginary solution. But now we know here on this one, at least we have to be on the lookout for that. All right. So I'm going to start my synthetic division here. This one you have to be a little bit careful. Notice that we go from to the 6th, to the 5th, to the 3rd. So got to make sure you include your 0 in there. I'm guessing that I caught a lot of you snoozing on that and forgot to write down your 0. So I know -1 can be used twice, so I'm just going to go ahead and use it twice. And now I don't know if it can be used 4 times or not, but I do know 2 can be used twice, so I'm going to switch and go to 2 now. And right here, I could stop and try to do factor by grouping. And in fact, factor by grouping would work here, but I'm just going to keep going and do my other divide by 2. And so that worked. Okay, at this point, I have a quadratic, so I'm going to stop. So because -1 gives me 0, I'm going to get x plus 1. And because it worked twice, I'll have 2 of those. Because positive 2 gives me a remainder 0, I'm going to have an x minus 2. Why did that just shut off? That is super strange. And because it worked twice, I'm going to have 2 of those. And then I still have this stuff left over. Can x squared plus 3 factor? Should be able to look at that and say no, right? Because it's a squared with a plus sign next to the constant like that. It's not a difference of 2 squares, so I know it's already not factorable. Okay, so that's my best factored form. Now I'm just going to take each factor and set it equal to 0 and solve. So I get -1 for the first 2, positive 2 for the second 2. I subtract 3 from both sides, square root both sides, and because I have a negative sign underneath my square root, I have to use an I, so I have plus or minus I root 3. And if you typed in square root of 3, oh, I'm sorry, never mind. Never mind. Everybody okay there? So there's my 6 solutions. Okay. Holy shnikes. So for 4, part A is 7. Part B is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, plus or minus 28, plus or minus, ugh, I'm already getting lost here. 14. Oh, I have a 16 in there too? Shoot. That means I had 8 also. Okay. Okay, so the rest of these are just coming down now. So there's plus or minus 28, and then plus or minus 32 then, and then plus or minus probably 42 or something. No, it's going to be 54 maybe, 56. There it is. You got it, dude. And then 112, and then 224. There they all are. What a nightmare. You're welcome. All right, we'll type this into our calculator. I'll pick the window from negative 224 to positive 224. That's ridiculous. There's no way I'm going to keep that. If I hit graph, the calculator goes for a little while, and it doesn't really look like it did anything. Now, is there a problem with my calculator? Did it just break? No, I just can't see it because I'm just too far zoomed out, right? So this is negative 200. So that's like negative 100. So that'd be like 50, 25, 10, and that probably will be good. So let's do negative 10 to 10, positive 10. Seems like that'll catch them all. We can always go more if we need to. So I do that, and kind of sketchy on what's going on here, right? I can't see that well enough, me personally, so I'm going to go again. Looks like if I go from negative 3 to positive 3, though, I'll still keep everything. So let's do that. Oh, good. I'm glad I did that, because there definitely is two things going on there. It was a little bit tough to see that all the way zoomed out as to where things were happening. All right. So I see 3 X-intercepts there. Do you guys? What are the 3 that you see? Let's start with this one that's easy to tell. What's that one there on the far right side? $2.6 maybe? That seem reasonable to you? Okay. And this one then is probably negative 2.6, the far left one. And then I'm guessing this one would be right here at negative 2. You buy that, everybody? Are any of those irrational? Yes, which ones? Great. Why are they irrational? They're not on the list. Good. All right. So if I go and do my bend, bounces, and straights, it should be easy to see that the negative 2.6 and positive 2.6 are straights. Those are used just once. What is negative 2? That is a bend. So how many times can that be used? Odd numbers, so 3, 5. Can't really be 7 because I have 2 straights already. So I could just have 3 or 5. If I make my list then, I have negative 2. I have my irrationals. There's 2 of those. I have my imaginaries, and I have my total of 7. So if that's 3, 3 plus 2 is 5, so I'd need 2 imaginaries. That's 5, and that's 2. That's 7 already, so there can't be any imaginaries in that situation. So again, the takeaway here is that it's possible that I could have imaginary solutions. That's what the table there at the end is going to tell me, is are there imaginary solutions possible in the problem? It's not going to tell me for sure if they're there. It's just going to tell me if it's possible that they're there. Okay. And then let's do the synthetic division. It's a 64, right? The second number is supposed to be 6. Thank you. All right. It should be a 4. It's going to make that a -8. That's going to make that a 1. A -2, so that's going to be a -12. Be a +24. Be a 40. That'll be, oops, -40. That'll be an 80. That's a -112. So 224, a -112, a +224. And then I know I can use that -2 at least 3 times. So let's just go again. That's +56, -56, +112. Okay. And we'll go one more time, because I know I can use it 3 times. Okay. So, you could try doing this again, but guess what? Ain't going to work. So what are we going to do here? Well, -2 gives me a remainder 0 3 times, so I have x plus 2 to the 3rd. And then I have this stuff. That's the polynomial x to the 4th minus 3x squared minus 28. That's in the quadratic form, right? Because I have something to the 4th, something to the 2nd, and then a constant term. So I can factor that using my factoring tree. I can't use synthetic division to get at it, but I can use my factoring tree. So what do I have that multiplies to give us -28 and adds to give us -3? -7 and +4. And because the middle variable is x squared, I know that that's x squared minus 7 and x squared plus 4. So there's my factored form. Now I just need to set each piece equal to 0 and solve. So I get 3 -2s. When I add the 7 over and then I square root both sides, I get plus or minus √7. When I subtract the 4 over and square root both sides, I get plus or minus square root -4. Because I'm square rooting a negative, I know I'm going to get an I. And because the square root of 4 is just 2, I'm going to have x equals plus or minus 2i. Okay. So that's that worksheet.